Welcome to another quick video on how to find surface area. During class, we investigated the idea of finding a fixed volume of 24 inches cubed and how surface area would vary, which led us into this idea of how can we calculate surface area of a rectangular prism without actually having to count all of the little square faces that we find on our prism. So just as a kind of a quick reminder here, hopefully you can see that. Pull out my really cool pointer. That surface area, listen to this. Surface area is always in 2 dimensions. We think about making nets or a flat pattern, and we label our answer in square units. So we'll start with this idea of a 3-dimensional cube, keeping in mind that the cube is always going to have the same length, width, and height. And so a lot of times you'll only see that in a cube, S equals, let's say 3 centimeters. Because in my cube, all of the sides will be exactly the same. So for the purposes of showing or reminding us, I could label this as 3 centimeters, 3 centimeters, and 3 centimeters. So in order to find the surface area, we want to know really what is it going to take to cover all 6 faces of this cube. And so if I draw in the other kind of hidden faces, I see that there are 6 faces, and I need to know the total area of all 6 faces. And so I'm going to just take a look over here and say, well, let's just find the area of the bottom face. And if the area of the bottom face is 3 times 3, or giving me 9 centimeters squared, I would then multiply that by the 6 faces, multiplied by 6 faces. And 9 centimeters squared times 6 faces is going to give me 54 centimeters squared. So it's very common because of the idea that this is a 3-dimensional figure, but now we're talking just faces, that we confuse our units. And so we just have to remember area is always square units, even though we're talking about a 3-dimensional shape. Currently, we're really visualizing this as a flat pattern. So this idea of that flat pattern is, what would it look like if I took that 3-dimensional cube that had side lengths of 3 centimeters. Just quickly draw that back in for you. And this idea of being able to look at that a little bit differently. So I'll do my best here to take, let's say that's the bottom. And that would be the front. And I'm going to fold down the top. So the bottom, the front, the top, and on one side of the bottom is going to be that other, that's actually not true. So if I folded that down, let's visualize this together. Fold the bottom, now my front and my top, so on the sides of my top is really where this left and right sides would be. And then we could even then say, okay, on the other side of that top would be the back. Now that you can see this flat pattern, we should be able to identify that each square face has the same area. So the bottom had a 3 by 3 square, and we know that the bottom and the top are the same, so this would be 3 and 3. And we know that the little right face would have a 3 by 3, so I'm going to fill in 3 by 3, meaning the left would have the same. And then quickly we can say, well, then also my front and back would be that 3 by 3. So the flat pattern is just a little bit of an easier way for us to see that in total, each face has an area of 9 centimeters squared. And if we were to add those 9, 9, 9, 9, 9, we would end up with 54 centimeters squared as our total surface area. So moving from the cube, we're going to talk about rectangular prisms and the ideal way in which we can find out the surface area for that. So rectangular prisms. And we've been talking about a rectangular prism being something along the lines of this. And then we can extend back to make this, well, that's not very good. To make this a little bit more three-dimensional looking, at least. And I'm drawing those little hidden faces so it's easier to visualize. The idea of having to cover all 6 faces. So our 6 faces here can be considered that top and bottom. And we've talked in class about how those are the same. And we can see that we have the front and the back. And we can see that we have, oh, we need a new color. How about an orange? A left and right. That will be the same. And so if I wanted to consider the dimensions for just a moment, I would indicate that this is the length. This is my width. And this is the height. So we can then continue on and say, well, in order to find the area of the top, I would really be thinking about the top or the bottom and saying, well then, what dimensions would give me the area? And to find the area of the top, I hope that you can see that we would say that that's length multiplied by width. And the area of the bottom would be the same. And then if we look at the front and the back, here's my front now, and we would see that we have the area of that rectangle can be found using length multiplied by height. And the same thing for the back face, even though it's somewhat hidden right now. And last, we can take a look at the left and right faces and indicate that that face can be found, at least in terms of area, as being the width multiplied by the height, and the width multiplied by the height. So we want to find the total surface area. I'm going to write at a little bit of an angle so that I can fit my rule in completely. But let's start with the top and the bottom, and I see that I have 2 lengths multiplied by width, which is going to be the area of, let's say, the top, multiplied by 2 so that we include the area of the bottom as well. And to that, for the total, we're going to add what we see as being the front and the back, which is the 2 multiplied by length and the height. And lastly, see that we have our left and right, which is 2w, or width, multiplied by the height. Remembering to label your answer in square units. So let's take this idea of what we just talked about and put it into action with a rectangular prism that has some real numbers. So make this kind of like a tall tower. I'm drawing those invisible faces. And I'm going to say that this is a, well, let's say 4 inches with the width of 3 inches and a height of 7 inches. And so I'm going to start by saying surface area equals, and I don't really need to remember the entire rule because it doesn't matter which way I get an answer, as long as I take into consideration all 6 faces. So if I start, let's say, with the left and the right faces here, I see that that's 2 multiplied by 3 by 7. 3 times 7. Plus, let's say, the bottom and the top. So that's 2 faces, and each face is 4 times 3. Plus what is now left as the front and the back. And coloring like this, I kind of take care of both of them. And the way that I would find the area of that front and back would be the 4 and the 7. And now I can just follow order of operations to get an answer. So we'll go to green, and we'll say this becomes 2 times 21, plus 2 times 12, plus 2 times 28. Continue to funnel. 2 times 21 is 42. 2 times 12 is 24. 2 times 28 is 56. And so at this point, we can go ahead and add together 42, 24, and 56. So most of you have a calculator on hand, or we can quickly just say 2 plus 4 is 6. 6 plus 6 is 2. Think about carrying that 1. So now this is 5, and 2 is 7. 5 more would be 122 inches. And hopefully you remember that that 2-dimensional surface area is inches squared. Okay, so on the next part of this video, I'm going to give you a rectangular prism, and we will find the surface area, and then just as a review, we'll also consider talking about volume. So take out a piece of paper and your pencil and go ahead and sketch these 2 rectangular prisms on that paper, and I'd like for you to find the surface area of prism A and the surface area of prism B, and then go ahead and find the volume of these 2 rectangular prisms also. And we will either go over these in class next week, or I will end up posting the answer to Edmodo. So just to recap, surface area is always 2 dimensions, or 2D, which means our answer will be labeled in square units, which could be square centimeters, inches squared, feet squared, units squared, whatever that is. We're thinking about that flat surface or that net idea of what it would take to kind of cover or paint the outside edge of a 3-dimensional object. So if you haven't already written it down or you need a refresher, we talked about surface area equaling 2 multiplied by the length and width, which is your top and bottom, multiplied by 2 times the length and height, which would be your front and back, and then 2 multiplied by your width and height, which would give you your left and right sides. I hope this video has been helpful, and we will continue to practice in class soon.